Now you were asked to prove that Ka times Kb is equal to Kw. Now what is Ka to start with? Ka means the acid dissociation constant. It means the acid dissociation constant. Okay. Now, according to the Vance Arrhenius definition of acid, he said that when an acid dissolves in water, it will form what? It will form hydrogen ion, or the hydrozonium ion, as the only positive ion. Okay. So if we have, let's say this is an acid represented with Ha, is in equilibrium. If it dissolves in water, let's say plus H2O in equilibrium, what will it form? Now, acids are proton donor, so this acid here will donate its proton to H2O. Now if this proton comes here, what will happen? This one becomes H3, so you have H3O plus, because a proton is what? H plus. That is what a proton is. Then plus. Now if this one enters here, what will be left here? First of all, you split this to give us H plus and A minus. H plus add here to give us H3O plus. Then what will be left here? A minus. So we have here as A minus. Now this A minus is a base. Why? Because it can receive a proton from this acid to form this again. That is why we said that the reaction is at equilibrium. Equilibrium reaction is that reaction that can proceed both in the forward direction and also in the backward direction. So this one here can also split to give us H2O. Then if one of its H plus now combine with this to give us what? HA. So the reaction can be reversed. So this is our equation for the dissociation of an acid. Now in this equation, what will be our Ka? Now we said the Ka is the acid dissociation constant, and it is the product or the concentration of the products all over the concentration of the reactant. Now paying cognizance of the states. This is aqueous state, this is liquid, this is aqueous, and this is what? Aqueous. Now while we are writing equilibrium constant expression, we are told that pure solids and pure liquids do not surface in the equilibrium constant expression because their concentration remains the same. So this, our Ka, would be equal to the concentration of the product is H3O plus, and that of the reactant, that of the product is H3O plus, which is this, then multiplied by A minus, which is this, all over. That here is what? HA only, the concentration of HA. Now water did not surface in the equilibrium constant expression because the concentration of water remains constant. So this is our Ka. Now how about our base dissociation? Now I told you that this is a base, this is a conjugate base. So if we pick this base out, let's say A minus, now react it with water, what will it form? It will form, if these two combine, it will form what? HA and then plus OH minus. Okay, because when this H2O split, it will give us H plus and what? O minus. Now this A minus here combine with this to give us what? HA, and then we are left with what? O minus, which is this, OH minus. So this is the base dissociation constant. Now let's write the states. This is aqueous, this is pure liquid, this is aqueous, and this is aqueous. Now every ion you see are aqueous. Are you getting it now? All ions are aqueous. Then HA is an acid, is aqueous. Then this one is liquid. Now what will be your base dissociation constant? Kb would be, we said, the concentration of the product, which is HA, and then that of the product also OH minus, divided by that of the reactant, which is what? A minus. Now another one again is H2O did not surface because a pure liquid. So our Ka times Kb is equal to you multiply what you have there. What is our Ka? Ka is H3O plus. Let me write it down here. Ka times Kb will be equal to Ka times Kb will be equal to, what is our Ka? Ka is H3O plus bracket A minus divided by HA times, what is our Kb? Kb is HA times what? OH minus divided by A minus. At this point in time, we can cancel out. HA cancel HA. A minus cancels A minus. So what are we left with? Ka times Kb is equal to H3O plus brackets. There we have OH. Are you agree with me that this is Kw? Because auto ionization of water is what? H2O plus H2O. Now when this reacts, this one will donate a proton to this, so this becomes H3O plus what? OH minus. Okay, and then Kw will be what? Kw in this case would be the concentration of the product, which is H3O plus and what? OH minus. Now you discover that there is no reactant because this is pure liquid, this is pure liquid. Pure liquid does not surface, so this is your Kw. So wherever you see this Kw, which is H3O plus and OH minus, you can put what? You can put your Kw. So this becomes Ka times Kb is equals to Kw. You've been able to prove that your Ka times Kb is equals to Kw. So that is the answer to that question. Now the next one says, if a solution has a pH, now the pH was given to you as what? The pH was given as 5.50. At temperature, the temperature does not matter. Calculate the concentration of OH minus. Now we know that pH, we can take two ways to solve this. We know that pH plus pOH is equals to 14. Let's use this method. I believe this method is shorter and quicker. Now if pH plus pOH is 14, so our pH is what? 5.50 plus pOH is equal to 14. Now let's make pOH subject to the formula by taking this one to this side. So this becomes 14 minus 5.50. So our pOH will be 14 minus this, give us 8.50. Okay, now what is our pOH? pOH is negative log OH plus, OH minus rather, negative log OH minus. Okay, so in this case we can now look for our OH minus, substituting in for pOH. pOH is what? 8.5 is equal to 8.50. This is 8.50, not degree, please. 8.5 then minus log OH minus. Now what do? Use the minus to multiply both sides, so this becomes minus what? 8.5 is equal to minus bracket minus what? Log OH minus. Now the reason I would do that is so that the minus can cancel out the minus from here. So our log OH minus now is equals to minus 8.5. So to find the OH minus, we find the antilog of both sides. Antilog means 10 raised to the power of log. So we have 10 raised to the power of log OH minus. Antilog means 10 raised to the power of anything rather. So this becomes 10 raised to the power of minus 8.5. Now when this antilog can cancel out log, because antilog is the opposite of log. Now when that happens, your OH minus will be equal to 10 raised to the power of 8.5. And then OH minus will give us 10 raised to the power of 8.5 is 10 raised to the power of minus 8.5 will give us 3.16 times 10 raised to the power of minus 9, or we can say it will give us 3.2 times 10 raised to the power of minus 9. And that is the solution to that question. Thank you for your time.